Hello, my name is Guillermo Ramos, and this is Physics of the Tippe-Top, a low-budget production. The Tippe-Top is an amazing toy that seemingly defies gravity by pushing the heavy side to the top. Today I will try to explain what is going on behind the scenes and what makes this strange act of physics happen. Join me in this wonderful adventure, and I hope we can both learn something new. Here is a demonstration of the motion of a Tippe-Top. Some things we want to know to understand the motion of the Tippe-Top are that things like to spin around a center of mass. Friction causes a force against motion, and torque causes a change in angular momentum along the torque. As an example of the first thing we need to know, we can use as an example of a system of two bodies. The bodies rotate not on the geometrical center, but the center of mass. The same is true for a rigid body. The rigid body will spin around the center of mass. This is important to know because, as we can see here, the point of contact in the curve of a Tippe-Top is not always underneath the center of mass. The other thing to know is that a torque causes a change in angular momentum along the torque. A good example of this is the classic precession experiment, where a spinning wheel experiences a force of gravity which causes the wheel to spin along the axis of the cord that's holding it instead of dropping down as expected. So how does the Tippe-Top actually work? The first thing to note is that when we first spin the Tippe-Top, we are applying torque, which causes the top to spin. This causes an angular momentum along this axis, pointing along the handle used to spin it. As soon as the Tippe-Top hits the ground, we already have angular momentum pointing along the handle. Because the top lands spinning, we know that it will naturally move off center, and there will be a friction force active along this direction. The force, because the center of mass of the top is not the same as the point of contact, causes the friction force to act along a circle. Because the friction force acts along a circle this way, using the right hand rule, we know that the torque will also be pointing down. Since the angular momentum is pointing along the handle, that same momentum will be shifting in the downwards direction along the torque. This will cause the Tippe-Top to drop, the Tippe-Top handle to drop until it reaches the ground. Here is a slow motion version of the Tippe-Top. Notice how the top spins both on the axis along the handle and the center of mass, causing it a little bit of wobble and the handle to drop until it reaches contact with the surface.